Hi dear students, welcome to Gita's classes. This is a continuation class, and in part 1 of this class we have seen some problems on Laplace transforms, and in part 2 we have seen problems on inverse Laplace transforms. In this class we are going to solve the differential equations, which is the main application of Laplace transforms. So before going to the problems, try to be thorough with all these formulas and theorems. All the proofs are available in the previous classes. Try to be thorough with these theorems and formulas so that you can find out inverse Laplace transform and Laplace transforms easily. Okay. So now solve the following differential equations by using Laplace transform. So first equation is y double dash plus 2y dash plus 5y is equal to e power minus t sin t, where y of 0 is equal to 0, y dash of 0 is equal to 1. So taking Laplace transform on both sides. So we are going to solve the differential equation. Main procedure is you have to take the Laplace transform on both sides and collect all the Laplace transform, that is L of y, and y is equal to, you have to find out that actually solving the differential equation. Here what is the differential equation? D squared y by d t squared, because in the right hand side we have t. So dependent variable is y, independent variable is t. Okay. So d squared y by dt squared plus 2 into dy by dt plus 5y is equal to e power minus t sin t. So solving this differential equation means find y as a function of t which satisfies the given differential equation. Okay, that is our aim. We have to find out y. So taking Laplace transform on both sides and y double dash, y dash and all, you expand using the Laplace transform theorems and collect all the terms of L of y, and y is equal to find the inverse Laplace transform. That is the procedure. Okay. So taking Laplace transform on both sides, we get L of y double dash is equal to. Before that, you please recollect the formulas, that L of f dash of t can be written as L of s into L of f of t minus f of 0, and L of f double dash of t is equal to s squared into L of f of t minus s into f of 0 minus f dash of 0. And L of f triple dash of t, if you want, generally we will get up to second degree equation only, second order differential equation only. Even if the third order is given, you can use this s cube into L of f of t minus s squared into f of 0 minus s into f dash of 0 minus f double dash of 0. This is the expansion. Okay, so just to substitute in this, in the place of f, I have y. Okay, so L of y double dash is equal to s squared into L of y minus s into y of 0 minus y dash of 0 plus 2 into y dash, L of y dash. L of y dash is s into L of y minus y of 0 plus 5 into L of y is equal to 1 by s plus 1 the whole square plus 1. So given y of 0 and the condition, initial conditions are given. So y of 0 is equal to 0, y dash of 0 is equal to 1. Substitute those values and collect all the terms of L of y in the left hand side. You will be getting s squared plus 2s plus 5 into L of y is equal to 1 by s squared plus 2s plus 2 plus 1. Okay. And simplifying, I will be getting L of y is equal to, bring this term also to the right hand side. Okay. So s squared plus 2s plus 3 divided by s squared plus 2s plus 2 into s squared plus 2s plus 5. And now using partial fractions, you have to split them, because in the denominator you have product of two functions. Okay. So y is equal to L inverse of 1 by 3 by s squared plus 2s plus 2 plus 2 by 3 by s squared plus 2s plus 5. In the inverse Laplace transforms, we have seen so many problems with using partial fractions. So if you want to go through that, please listen to those classes so that you will become thorough with these things. Okay, you will understand how to use that partial fractions. So 1 by 3 into, now 1 by 3 can be using the, we know that L inverse is also linear. So using the linearity property of Laplace, inverse Laplace transform, I can take 1 by 3 outside and L inverse of 1 by s squared plus 2s plus 2. Again split them, 2 into 1. So this 2 can be written as 1 plus 1. So s plus 1 the whole squared plus 1. Similarly 2 by 3 can be taken outside. L inverse of 1 by s plus 1 the whole squared plus 2 squared. Here I want 2 squared. Here s 1 by 1 only. So here you have 2. So multiply and divide it by 2. So that I can write it as 1 by 3 into e power minus t sin t plus 1 by 3 into e power minus t sin 2t. Okay, so e power minus t by 3 is common. So sin t plus sin 2t. That is the answer. Next is d squared plus 1 into x is equal to t into cos 2t. Let the given equation be 1. And given that x is equal to 0, dx is equal to 0. That is x is equal to 0 and x dash is equal to 0. At t is equal to 0 means you can write this equation as x of 0 is equal to 0 and x dash of 0 is equal to 0. That only they have given like this. Dx is equal to 0, at t is equal to 0. And what is this equation? X double dash. And please remember in the previous problem, dy by dt, that is dy by dt, d squared y by dt squared. So y was the dependent variable, t was the independent variable. In this problem, x is the dependent variable and t is the independent variable. That is d squared x by dt squared or x double dash plus x dash is equal to t into cos 2t. This is the given equation. And taking Laplace transform on both sides, L of x double dash plus L of x, sorry, not x dash, yes, x is equal to L of t into cos 2t. Expanding using the same function. Here you have x dash, x double dash, therefore L of x minus s into x of 0 minus x dash of 0. Now substitute the values, given values, initial conditions, so and collect all the L of x terms. Okay. So s squared plus 1 into L of x is equal to, L of x is equal to, bring this s squared plus 1 to the right hand side. Again apply partial fractions and split them into a, b, c. That is a by b by c by. Okay. So you can write it as 5 by 9 L inverse of 1 by s squared plus 4 and separate them L by 3 L inverse of 1 by s squared plus 4 the whole squared minus 5 by 9 L inverse of 1 by s squared plus 1. Now, first term we can find out easily, third term also you can find out easily. Here how will you find out? You multiply and divide by s. So that 1 by s formula we can use. In the previous class also I have done one problem with inverse Laplace transform with 1 by product with 1 by s. Okay. So using that you can write it as 1 by s into s by s squared plus 4 the whole square minus 5 by 9 sin t. So this can be written as, this is the formula. If you want to know in detail, please go through the previous class. I have explained how to do these kind of problems. Okay, that is integral 0 to t f of u du. So if you apply this and simplify, you will be getting this the answer. 4 by 9 sin 2t minus 5 by 9 sin t minus t by 3 cos 2t. Okay. And the next is also similar question only, d squared plus 9 of y is equal to cos 2t, that is y of 0 is equal to 1, y of pi by 2 is equal to minus 1. This is a little different problem. Here y dash is not given. So here if it is y dash is given, then we will directly substitute. Here y dash is not given, so assume that y dash of 0 as a. Okay, it is not given, so take it as a. Let assuming y dash of 0 is equal to a. Okay, using that you solve, and solution is easy only, you can solve. Then after that, this is the solution, a by 3 into sin 3t you will be getting, all the other terms will be easier. Now we have to find the value of a. For that use the second condition, one more condition is given now, so using that condition we have to find the value of a. So y of pi by 2 is equal to minus 1. So substitute, this is the solution in which a is to be found using the given condition. Okay, so y of pi by 2 is equal to minus 1. If you substitute, you will be getting a is equal to 12 by 5. Now again substitute this a value in the previous equation, that is equation number 2, and simplify, you will get this answer. Okay. Next is d squared x by dt squared minus 2 into dx by dt plus x is equal to e power t. Again writing the similar equation, it is similar only, similar to the first and second problems. So L of e power t, right hand side also you have to take and collect all the terms of L of x and bring it to the right hand side. Then simplify. S minus 1 the whole cube. S plus a or s minus a means you have to use first shifting theorem. Okay. So in inverse Laplace transforms, I have explained clearly all these kind of problems. Please go through that. Similarly, one more problem, 4 into e power minus 3t. Same procedure is going to be the same. If you understand the concept, you can do any kind of problems. Okay. Only thing is you have to be thorough with Laplace transform and inverse Laplace transform also. Okay. Hope this will be useful for you. Please give a like and share it with your friends so that it will be useful for them also. Thank you so much for listening.